Now let's look at an example where we have a continuous distribution. The PDF of x is given as x plus 1 half in the interval from 0 to 1. So we have something like this. From 0 to 1, we have this PDF. Here, this is 1 half, and this is 3 over 2 at 1. Okay. Um, the area below this PDF is obviously 1. And the random variable y is defined as the square of x. Okay. Um, we would like to find the distribution of y. And here you see x is a number between 0 and 1, which gives me the domain of y also, because x will be between 0 and 1, and its square also will take a value between 0 and 1. Okay, so determining the domains is quite significant, quite important when you deal with functions of random variables. What values can x take, and depending on that, what values y can take. That's important. And here, again, let's apply the general approach. So the CDF of y is equal to probability y less than or equal to y. So instead of y here, write x squared. Okay, so probability of x squared less than or equal to y. Since we know x is between 0 and 1, the only case where x squared is below y, I can achieve when x is below square root of y, right? Obviously, y here will be um, a positive value or a non-negative value, because if y is negative, obviously this probability is 0. So always be careful about that. Okay, so how can I write this? The probability of x less than or equal to square root y. I can write this using the integration of the PDF of x from 0, because the smallest value x can take is 0, up to square root y. So implicitly, I'm just saying this is equal to 0 less than or equal to x less than or equal to y, square root y. Okay. If you integrate this, what you get is this: y plus square root y divided by 2. This is the CDF of y, but be careful again. In fact, I should have written this as, well, it is 0 when y is below 0, because no outcome is negative. Okay. And then it's this expression where y is between 0 and 1. And if you look closely, when you just plug in 1 in this expression, 1 plus square root 1 divided by 2, you get 1. As expected. Why? Because you reach the probability of the sample space at y equals 1. So after 1, the CDF should be 1. Okay. Now, when you take the derivative of this function, of course, you get the PDF, which is 1 over 4 times 2 plus 1 over square root y. And obviously, this is for y in the interval 0, 1. Okay. Now here you see these functions, um, the PDF of each of these random variables. Here, the PDF of x is given to us, x plus 1 half, and that's plotted with this curve. And the PDF of y is plotted here, 1 over 4 times 2 plus 1 over square root y, between, of course, 0 and 1. Of course, when y is negative, this is 0. And also when it is beyond 1, the PDF is also 0. So the only probability we have is between 0 and 1. But you see, the probabilities are concentrated in the values smaller to closer to 0, in the smaller range. Why? Because x here is a value between 0 and 1, and we are taking its square, so it's going to take it's going to get smaller and smaller. Okay, so y will be a number less than x, in fact. Therefore, it should be no surprise that the probabilities are concentrated towards zero. Okay, so in fact, if you take the limit as y goes to zero, the PDF value goes to infinity. But if you integrate it, in fact, between 0 and 1, you should see that the integral equals 1. Okay? Okay, so this is the PDF of y. Um, and therefore, this is the way to obtain the PDF of y from the relationship between y and x.